For today's online class, we are going to be doing trigonometric ratio of special angles 30 degrees and 60 degrees. So for this particular one, we're going to be making use of an equilateral triangle. An equilateral triangle is a triangle that has all the sides and angles to be equal. So now let's assume that this here is an equilateral triangle. And an equilateral triangle has each of the angles to be 60 degrees. So this is 60 degrees, and this is also 60 degrees. And since the sides are also equal, I'm going to be having 2 here, 2 centimeter, and this here is 2 centimeter as well. Now, if I should bisect this equilateral triangle, if I should bisect one of the angles now, I'm going to be having that this here is 30 degrees and this here is 30 degrees. So if I should bisect it, half of it should be this, 2 centimeter. This here will be 30 degrees because it is half of it. This here will be 60 degrees. This here will be a right angle triangle. Since I also bisected this side, I'm going to be having 1 centimeter here. So I'm going to be using this angle here for the trigonometric ratios of special angle 60 degrees. And I'm going to be using this side for that of 30 degrees. Now remember, our trigonometric ratios. Okay, so I'm going to be dividing this into two. So I'm going to be using this side for that of 30 degrees and this side for that of 60 degrees. So I'm going to be starting with sine. Sine is opposite over hypotenuse. So if this is the angle that I'm making use of, here will be opposite and this here will be my hypotenuse. Okay, but before then, we have to find the value of what we have here. So if I should make use of a Pythagoras theorem for this is my hypotenuse. So I'm having that 2 squared is equal to 1 squared plus, let me call this x squared. 2 squared is 4, right? 4 is equal to 1 squared is 1 plus x squared. If I should collect like terms, I'm having that x squared is equal to 4 minus 1, which is 3. So my x should be equal to root 3. So I'm having root 3 here. So now my sine 30 degrees is going to be opposite over hypotenuse, and my opposite is 1 centimeter and my hypotenuse is 2 centimeter. So sine theta is going to be equal to 1 over 2, which is also equal to 0.5, and that's it. Then for that of 60 degrees, sine is again opposite over hypotenuse, but since I'm making use of 60 degrees, my opposite will be root 3 and my hypotenuse will be 2. So sine theta here is going to be root 3 over 2, and that is it. Now the next one, which is cos. Cosine is equal to adjacent over hypotenuse. So for that of 30 degrees, my adjacent is root 3 and my hypotenuse is 2. So that's it for that of 30 degrees. And then for that of 60 degrees, cos again is adjacent over hypotenuse. My adjacent here is 1 centimeter and my hypotenuse is 2 centimeter. So I'm having 1 over 2 here, which is equal to 0.5. Then for tangent, tan theta here should be, tan is opposite over adjacent. So since we are considering 30 degrees, my opposite is going to be 1 and my adjacent is root 3. So I'm having 1 over root 3. If I rationalize this, I'm getting multiplied by root 3 multiplied by root 3. So this is equal to root 3 over 3. Then for that of 60 degrees, tan theta is equal to, tan is opposite over adjacent, and this is my 60 degrees. Opposite is root 3, adjacent is 1, root 3 over 1. So I'm getting root 3. And that's it for special angle 30 degrees and special angle 60 degrees. Thank you.